All right, welcome to this explainer. Today, we're completely demystifying the core technology that powers modern cloud deployments. Honestly, let's just forget the buzzwords for a second, right? We're going to get straight to the architectural heart of how today's biggest applications are actually shipped and scaled.
So have you ever wondered how tech giants like Spotify, Amazon, and Netflix manage to ship their software so lightning fast? I mean, how do they scale instantly to handle literally millions of users without even breaking a sweat? Well, the secret to this instant, massive scaling is a really revolutionary concept called containerization. And right at the absolute heart of it all, that's Docker.
Okay, let's dive right into this. Here's our roadmap for today. We'll kick things off with the secret to scaling. Then we'll compare VMs versus containers. After that, we'll look inside Docker architecture, move on to cloud setup and execution, and finally, we'll wrap the whole thing up with essential Docker commands.
Section 1. The secret to scaling. Let's look at why Docker is absolutely everywhere.
You know, the numbers really just speak for themselves here. If we look at the 2024 Stack Overflow survey, Docker completely crushed the competition. It was voted the #1 preferred developer tool by over 53% of respondents. Think about that. Whether you're a data scientist, a cloud engineer, or an AI specialist, knowing Docker, well, it's really no longer optional. It is a foundational skill for modern application architectures.
So why the intense love from the industry? It really boils down to 4 massive features. First up is environment reproducibility, meaning you get the exact same results anywhere you run it. Then we have dependency management, which isolates exactly what your app needs without causing conflicts with other software. Third is portability. We're talking about moving a workload from AWS straight to your local laptop in just seconds. And finally, version control. Since configurations are just scripted text files, tracking your changes is practically effortless. Honestly, these features solve the absolute biggest headaches in tech.
And speaking of headaches, man, if you've worked in tech for more than a week, I guarantee you've heard this infamous excuse. But it works on my machine, right? A developer writes perfect code, sends it off to the testing team, and out of nowhere, it just crashes. Why? Because the environments didn't match. Docker was literally invented to end this exact nightmare of mismatched environments and dependency hell once and for all.
Moving on to Section 2, VMs versus containers, and the historical shift that got us here. Okay, here is the foundational definition you absolutely need to remember. A container is a lightweight, isolated software process that actually shares the host operating system's kernel. What that means is it encapsulates your code, your runtime, your configuration, and your libraries all into one tidy, self-sufficient package. It's got absolutely everything it needs to run successfully, just neatly bundled up together.
And this brilliantly illustrates the core concept. Just think of actual, physical shipping containers. If you pack all your furniture into a standard steel shipping container, you can throw it on a truck, a train, or a cargo ship. And when it arrives halfway across the world, you open the doors and find the exact same contents in the exact same arrangement. Docker does exactly this, but for your software. It is just perfect portability.
Now, what's really interesting is when we contrast this directly with traditional virtual machines. The difference is just stark. VMs are heavyweight. They require a hypervisor and they run multiple full operating systems, which honestly makes them incredibly slow to boot and super resource heavy. Containers, on the other hand, use a Docker engine to share a single OS kernel. This makes them so incredibly lightweight that they can start up in mere milliseconds. The resource savings here are just massive.
Let's jump into Section 3, Inside Docker Architecture. Time to look under the hood. Let's see how this all builds into a complete system. When you type a command, it starts right at the Docker client. The client basically acts as your interface, and it sends that command over to the Docker daemon, which is the true brain of the operation sitting on the host machine. Now, if the daemon needs a specific file to build your container, it reaches out to step 3, pulling images from a registry. The most famous one, of course, being Docker Hub. Notice I just mentioned images. It is absolutely crucial to understand this definition. A Docker image is a read-only binary template. It contains the application code, the runtime, and the configuration. I like to think of the image as the blueprint, or like a cookie cutter that's stored safely on Docker Hub. The container, on the other hand, is the actual baked cookie. It's the live, running process that gets created from that reusable template.
Section 4, Cloud Setup and Execution. Let's talk about execution in the cloud.
Now you might be wondering, why not just install Docker on my personal laptop? And hey, while you certainly can use local desktop tools, spinning up an Ubuntu EC2 instance on the AWS cloud is highly, highly recommended. Why? Well, because you're working in a real-world production environment. It builds legitimate, resume-ready DevOps skills, it gives you a standard Linux experience, and best of all, a basic instance is literally 100% covered under the AWS free tier. It really is the smartest way to learn.
And finally, Section 5, Essential Docker Commands. Time to hit the command line.
So the crucial point here is how we actually prepare our environment before we run anything. First up, we use Docker pull to download our desired image from Docker Hub right down to our machine. Next, Docker Images access sort of an inventory check. It lists out all the local images you've successfully downloaded. And finally, Docker Create uses that image to prep a container, staging it perfectly for us without actually starting the execution process.
Okay, so once it's staged, we enter the active management lifecycle. You're going to use Docker start to get that container running. To verify what's currently active on your host, you just type docker ps. When you're all done, Docker stop will halt the container gracefully. But here is my absolute favorite command, docker exec. Specifically, if you run docker exec it, it allows you to open an interactive terminal and log directly into the running container's shell, almost exactly as if it were a physical machine.
But hey, remember our core concept from earlier? Despite feeling like a completely separate virtual machine when you log into it, under the hood, a running Docker container is simply an isolated software process. Seriously, if you log into your Ubuntu host and run the standard Linux command psaux, you will actually see your container running right there, side by side with all the other standard system processes. It is elegantly simple and just incredibly efficient.
And that brings us to the climax of our setup, the ultimate test to prove everything is working perfectly. You just type docker run hello world. In a fraction of a second, your Docker client talks to the daemon. The daemon realizes, oops, I don't have this image, pulls it from Docker Hub, creates the container, runs the process, and echoes a friendly greeting right back to your screen. It is absolute magic in milliseconds.
Which leaves us with a final, very exciting thought. Now that you understand exactly how to perfectly reproduce and ship code anywhere in milliseconds without any fear of dependency conflicts, what are you going to build next? You now have the foundational knowledge to start building modern, scalable microservices just like the tech giants do. Thank you so much for joining me on this explainer, and I honestly can't wait to see what you create.